This presentation is delivered by the Stanford Center for Professional Development.
All right, today we're actually going to go over some more of the graphic stuff you saw, talk a little bit more about objects and classes, and get into variables and values and all kinds of goodies. Any questions? Alrighty, then let's just dive right in. So one of the main topics for today is this thing called a variable. And a variable, you know, like variables come up in mathematics, and it's like, oh, x and y are variables, right? And there are these things, and we do all these manipulations on variables. In the computer science world, they're really friendly, right? You don't need to worry about integration or differentiation or, you know, those kind of variables. Variables are kind of your friend. And basically, all a variable is in the computer science world is it's a box. It's a box where we stick stuff. And the stuff we stick into that box can change. That's why we call it a variable, because it's a box that has variable contents. And you think back, you know, in the days of yore in math, and you're like, oh, yeah, that's kind of like x. You could have different values. Yeah, it's basically just like that. So in computer science, what we think of as a variable is each variable has three things associated with it. It's got some name, and that's just how we refer to that particular box. It has a type, which is something a little bit different than in mathematics. But the type basically says, what kind of thing does this box store? Some boxes store numbers, some boxes store letters, some boxes will store other things, like little objects in the world. But a type is just what's stored in that box. And then there's a value. And the value, as you can imagine, is just what's in the box. It's what's the actual thing that's in there, right? If it stores a number, it might store, for example, the value 3. And that's just the value. And it may have some name associated with it. And how do we actually name these? There's actually a rule, and it's not a very complicated rule, but a very simple rule you need to remember for what are valid names for variables in Java. So valid name, so this is how you actually name these puppies, has to start with a letter or an underscore. So it starts with a letter, like one of the alphabetic letters, and it can be upper or lowercase, or the underscore character. Okay, and that's kind of, you know, underscore. It's down at the bottom of the line. Okay? And then after you have that initial letter or an underscore, then after that you can have any number of letters, numbers, that's like the number digits, like 1, 2, 3, 4, you know, 0, etc., or underscores. Okay? So you can't start with a number. You have to start with a letter or an underscore. For most purposes in this class, just think about them as letters. We're not actually use underscores. You might occasionally use numbers. You can actually have numbers after the first letter. There is one slight caveat to this rule, which is you can't have any variables that's name is the same as some what's known as a reserved word in Java, which means its name can't be the same as some special word in Java. Like the word class is a special name in Java. And there's actually a page in your book, I think in chapter 2, that lists all the special names. It's like out of the English language that has about 127,000 words, I think there's like 40 in Java that you can't make a variable name. Okay? You have lots of other choices. As a matter of fact, there's lots of things that don't have to be valid words in English. They can just be any name that follows this rule. The important thing to think about in terms of the name, and this is one of the good software engineering principles, is make your names descriptive. If you have a program that's maintaining, for example, the balance in a bank account, a real good name for the place where you store the value of the balance would be something like balance. A real bad name would be something like A. Because no one knows what A is. They're just like, hey, it's A. Yeah, I know what A is. Someone says, yeah, A is balance. Someone says, no, 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 in my program, A is actually how many miles I bicycled today. And you're like, no, 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 man, A was balance. Well, if it's called balance, there's just no ambiguity. So give them descriptive names. So that's kind of the name part of this. The next thing is, what's this type all about? What are different types that you can actually have? And there are some things that we refer to as primitive types. These are the types that have these smaller developed brains and whose knuckles drag on the ground. No, they're just the types that are built into Java. Okay? And some of the basic types we have is something called an int, which is short for an integer. But we actually write int. So int, int, is the name of the type. Okay? And this is an integer value. It's just going to store some whole number. Basically, it stores a number between minus 2 billion and plus 2 billion. But for all intents and purposes, you can just imagine you can store any integer in there. Okay? There's also, besides integers, what other kinds of numeric data do we have? People already know. It's like, I would think it would be like real values, but a bunch of people are already saying double because you read ahead and you've done the assignment the way you should. And that was kind of a mini social that both went to the same person. There's a thing called a double. And a double is actually some real valued numeric value, right? It's something like 2.3 is a double, or even 2.0 can be a double. Okay? Why is this thing called a double? Anyone know? As opposed to like a real? Yeah, it's a double. But there's this wonderful group of people called the IEEE, which is like the Institute for Electrical and Electronic Engineers. They come up with all these standards for things. Anyone a member of the IEEE here? No one? Oh man, join and pay your dues. It's a good time. I'm not actually a member myself. Shh. But what those folks actually do is they come up with standards for things, and one of the standards they came up with is how do you represent numbers that are real valued numbers inside a computer, right? Because remember, a computer only understands ones and zeros, so how do you actually represent a real valued number? And so there's a standard, and part of that standard has to do with the precision of the number. How many digits, in some sense, in a rough approximation, can you store? And double stands for a double precision real number. And so for the purpose of this class, all real valued numbers that we're going to use are just of type double. Okay? There's a couple other types that I'll just mention now, and I'll actually go into them in much more detail in a couple future classes. One is called Boolean. And if you've ever heard of Boolean logic, this is a logical value. So this is just essentially true or false. And we'll talk about that in excruciating detail next time, but I'll just let you know that there's a type called Boolean. There's also a type called char or car. And as you can imagine, it's because we like sort of the first syllable of most things, and this is the first syllable of character. Okay? And so we'll also talk about this in, a couple weeks' time when we actually get into some things with characters. But that's just a character. It's a variable. It's a box that stores a character. There's a box that stores an integer, a box that stores a real value, a box that stores true or false, and a box that stores a character. Those would be the different types of them. So one thing so that's kind of types, at least some of the basic types. And then when we think about values, what we actually store in this box, people always get uncomfortable when they see int and they see double, right? And they sort of say, but Meron, like 2 is an integer, right? And I'm like, yeah. And they're like, but you just told me 2.0 is a double, right? And I'm like, yeah, 2.0 is a double. And so the natural question is, why? Why do we have both these things? How come like all integers aren't subsumed by the real values, right? You're kind of the mathematician type, and you're like, yeah, there's like strictly more of these than there are of these. So why aren't all of these just subsumed in here? Why do we even have in this integer type? Okay? And the reason we do boils down to a very simple question. And the simple question you want to ask yourself is how much versus how many? Okay? So if you ask someone, let's say you, ask me, just so I won't embarrass you, how much do you weigh, Meron?
How much do you weigh?
I weigh about, 155.632 pounds. Okay? That makes perfect sense, right? If I could put a decimal point, I can put as many numbers after it, or I could just say 156. Right? And those are both valid kinds of things. Now, you could ask me, hey, Meron, how much children do you have? I have 2.3 children. Does that make any sense to you? Yeah, it's like we had 3 until that grisly accident. No. It's that there are sometimes, I know, that's just horrible to say. We actually have 1, and he's just fine. There are some times in the world where you care about counting. And when you care about counting, it doesn't make sense to have fractional values. Those things are integers. They are a how many kind of value. When you're thinking about how much, that's a double value. And you actually want to keep these distinct. Because if I ask you, what's the next number after 1, you say 2. Because you're thinking integer. And that's perfectly right. And if I say, what's the next number after 1.0, you say... Yeah, you start mumbling and you're like, well, it's not 2.0. That would have been the obvious answer, and that's probably not it. It's, how about 1.000001? And I'm like, no, you missed a couple zeros in there. Just keep going. Wait till the end of the quarter, then put that 1 and come back and talk to me. In real values, there is no next value. Okay, so when you care about counting, it doesn't make sense to use a double. That's when you want to have an integer. And so having these things be a distinct type actually makes sense. And you'll kind of see that as we go along. Okay? So the value is basically just what you're actually going to put into this box over here, and it's going to be some of the values that we actually talk about. So let me show you some examples of how we might use variables, what the syntax for variables actually is in Java. So what we need to do with variables before we use them in Java is we need to declare variables. It's kind of like declaring your love. If you're going to have some box somewhere that's going to store something in it, you need to come tell the world, hey, world, I got this thing called X. It's cool. Check it out. Here's how you do that in Java. You say int x. Okay? What that does is you specify a type for your variable. What's the box going to hold? You specify a name for that variable. In this case, the name is x. And because all statements end with a semicolon, just like you saw in Carol's world, we put a semicolon. What does this do? it creates a box somewhere in the computer's memory that's name is x that's going to store an integer in it. Right now, what does it store? Nothing. We haven't told it anything to store in particular. And so in Java's world, unless you initialize, you always want to think about initializing a variable, giving it some initial value to start off with. And there are some rules that we'll talk about as we go along regarding when Java will automatically sort of give you a 0 value in there, and there's times when it doesn't, and sometimes it can get a little bit confusing. So the general rule you want to remember, and it's also good software engineering, is give variables an initial value when it makes sense. Okay? So how might we give it an initial value? Well, on that same line, rather than just putting the semicolon there, we could say x equals 3. And what that does is it gives an initial value of 3 to x. Okay? So you could actually have the declaration of the variable without the initial value, but you always need to give it an initial value before you use it. So a lot of times we just give it the initial value when we actually declare it. Okay? If we wanted to have something of type double, maybe something called y, we could have double y equals 5.2. And what that means is somewhere in memory we have this thing called y, which has value 5.2 in it, and it's just a real value. Okay? So the general form for how you do these declarations is you say type, and I'll put little squiggles underneath these to let you know that these are this is the general form. The name, and then potentially an equal sign and some initial value. Some initial value followed by the semicolon. And that's how you do the declaration. And so the question that comes up, where do you actually make these declarations? And the place you will generally, at least for the time being, make declarations of values or declarations of variables is inside methods. So when you create some method, like you have public void run, and you're going to put everything that's going to go inside run in there, you could, for example, have this line in there, and this would create x with a value of 3 and y with a value of 5.2, and you wouldn't have the general form there, but for example, you could have those declarations inside run, and what that means is you have those variables created with some values available to you inside this method called run. They're only available to you inside that method called run. They're not available to you in some other method, and we'll talk about how you get values passed around between different methods in a few days, but for the time being, when you have your variables, they're only available in that method. Okay? So any questions about that? Variables or values? If
you house it inside the public run method, will a private method within that run method be able to take that variable?
Well, you won't be defining another method inside run, right? You'll be defining another method that's separate from run. It's just a separate method. It won't be available in that separate method, and it doesn't matter if it's public or private. It's just not available there. So this public or private thing that you have here doesn't affect the visibility of your variables. Your variables are always only visible inside the method in which they're declared and set up. Okay? Now, one other thing that we did when we sort of, did this equals thing over here, or if we wanted to, we could have actually done this in 2 lines. Rather than setting up x initial value there, we could have said int x, and then we could have said x equals 3 over here and gotten the same effect. And when we say x equals 3, this equals is not equals in mathematics. It's actually what's known as an assignment statement in Java, or in most programming languages. And the idea is we're taking some value over here, that's what's on the right-hand side of the equals, and assigning it to whatever variable is listed over on the left-hand side of the equals. So we're assigning that value. Okay? And so the general form for an assignment, let's just do that over here, is pretty straightforward. You just saw it. Is variable, and this is the name of the variable, so I'll squiggle, equals some value or some expression for a value, and we'll talk about expressions in just a second with a semicolon at the end of it, and that's how you assign a value. You can assign values multiple times to a variable. It's a variable. The contents change. So you could say, hey, x equals 3, and then down here somewhere, hey, x equals 4. And when you get to this line, up until you get to that line, from here to here, x will have had the value 3, and when it gets to this line, it'll stick a 4 in the box. And that's perfectly fine, because x is a variable. As long as everything you stick in there is of the type of which x is declared, you're OK. Okay? So what that also means is when you're doing assignment, you can do things that are perfectly fine in programming that to mathematicians, they just go nuts. They go crazy, like veins just burst in their head, and you hear these popping noises and people dying in the streets, which is you can say, hey, I have some variable called total. Let me create some variable int total, which I'll give some initial value like 10. And that's a good time. And then I say, hey, total equals total plus 1. And if you're a mathematician, you look at that and you say, no, man. Total can't equal total plus 1. That's just not right. Unless, and then you get into this whole philosophical question about, if this is like total is equal to infinity, and it's like, no, that's not what we're talking about. We're talking about assignment. This isn't equals, this is assignment. So what it says is evaluate the right-hand side, okay? Total, what was total's previous value? Go and looks it up in the box. Over here you have some box for total. Its value was 10. It looks it up. It says, oh, that was 10. I'm going to add 1 to it. That gives me 11. What do I do with that 11? Stick it back in the box named total. So it just says, okay, and it puts an 11 over here, and that's perfectly fine. So it's perfectly fine to do something like this where you take the old value for a variable, you do some manipulation on it, and you stick it back into the same variable. Okay? So, with that said, now that you know about variables, we can go back to a couple of the programs that you saw last time, and things will now begin to make a little bit more sense. So if we come to the computer, remember our little friend, add two integers that you saw last time. Suddenly, the world opens up a little bit, and we say, yeah, add two integers is a console program, right? So it's going to write some text out to a console somewhere. And we have our run method. We print out a line. We know that the method println, when we say that, whatever we put inside the double quotes gets printed to the screen. So it prints out this program adds two numbers. So we execute that line, and after we execute it, it writes it out, and it comes to the next line. Lo and behold, what have we done here? We've declared a variable named n1. What's the value for that variable that we're going to assign to it? We're going to call some method. The method we're going to call is something called readInt, and this is a method that's provided for you in console programs. All console programs can do this. The way it works is you give it some text between two double quotes. It writes that text on the screen, just like you saw last time, and asks for input from the user. Whatever value the user types in and hits enter, that number is the value that gets what we call returned by readInt. It's the value that after readInt executes says, hey, I got this number from the user. Here's that number. It's kind of giving it back to you. Do what you want. What are you going to do with it? You're going to assign it to the box n1. So here's the box for n1. We execute this statement. It's coming. It's going to print, enter n1 on the screen. It's going to ask us for a value. Let's say we type in the value 17, and it sticks that 17. So this expression over here evaluates the 17. It sticks 17 in the box for n1. Goes to the next line. Now it declares n2. We have some box. Its initial value is also going to come from the user via this readInt method. So we call readInt. It asks us for another value. We type in 25, and it sticks that in the box. Now we're going to declare another. We're just declaring until the cows come home, right? Declaring's fun. It's cheap. It's easy. Do it. Do it often, right? So we're going to declare another variable, total. So we have another box over here for total. And the value of total that's going to get assigned there is just whatever value is in n1 plus n2. So to evaluate this side, it says, I need to look up the box n1. So at the point where it reaches this line, it evaluates whatever's in n1. This isn't some truth that holds for all time. It's just an assignment that it does when it reaches that line. So it says, find out what's in n1, add it to what's in n2. That'll give you the value 42. Stick that into total, which is what you get. And then the last line says, I'm going to print something to the screen where the total is. And then you see these funky pluses. And you're like, whoa, man. I thought plus was like adding things together. What's going on? You're like trying to add. This thing's got the value 42. I know that because it's in the box. You're trying to add 42 to some text? That's not right. Well, in most worlds, it would not be right. But it turns out in the Java world, it's perfectly fine. And when it sees something that's some words with a plus sign, this plus sign here is not numerical addition anymore. This is essentially you can think of as a concatenation operator. It says take whatever text is here and add to that text the textual form of this value. Well, the textual form of 42 is just the characters 4 and 2. So it sort of adds that 42 here and then adds to the end of that a little period. So it concatenates all those things together and then prints them out and says the total's 42. Okay? So any questions about the program? If you're feeling good, like you understand what just went on in the program, nod your head. Rock on. That's what I like to see. All right. So with that said, we can go back to something else we did last time, right? So now you know all this variables and assignments and types, and you're like, hey, Marilyn, yeah, that's all good and well, but last time you were telling me about like classes and objects and drawing stuff on the screen. Like, what's up with all that? And this is the time where we actually do sort of the Reese's peanut butter cup. Like it's two great tastes that taste great together. We take some objects over here and some variables over here, and we just slam them together. And now you're going to have variables that contain objects. They taste great, all right? So here are some of the objects that you considered last time, right? We had things called or some classes. You had the glabel class and the grect class and the goval class. These were all these graphics classes, like a label that wrote some text out, or a rectangle, or an oval. I'll show you examples of all these things this time. And these guys were actually all classes that are part of a hierarchy of other classes, and the other classes they're all part of is G-object. So what G-object is a G-object is a class. Don't let the name fool you. Some people see G-object and they think, oh, that must be an object. No, G-object is a class. It just means a graphics object. And guess what? A rectangle or an oval or a line or a label are all different graphics objects. So what that actually looks like in terms of the hierarchy, just like you saw last time, is the classes are represented kind of like this in the hierarchy. All of these classes are actually G-objects. Okay? They're all subclasses of G-objects, which means they're specializations. So any behavior that G-object has, all of these things have, but they might have their own specialized behavior as well. Now, the interesting thing about all this is that when you have classes and you create objects, you can store those objects in a variable. You can say, give me a variable that is a box, and the type that that box holds is an object that's the type of some class. So all classes can actually be used as type names. Okay? Now, that's kind of funky. Let me show you an example. Okay? Here's another program you saw last time. Now, we can just kind of reveal the mystery about variables. We have this program, hello program, that extends the graphics program, right? So this is going to draw some pictures. Well, what are we actually doing on this first line? Hey, we're doing a declaration and an assignment on the first line. What's the type of our variable? It's a glabel. So we use the class name as the type. The name is label. So we have a box called label, and what that box is going to hold is any object of the class glabel. Okay, so that's the type. It's going to hold any object. And the question comes up, how do we get an object of type glabel? And here's the funky part. The way we get an object of type glabel is we have to ask for a new glabel. So we give the name of the class here, and classes, depending on the class, and you'll see some examples of this, will take in or are given some initial values for what we refer to as parameters. And these parameters are all separated by commas. But it's some initial values that this object uses to sort of set itself up. It initializes the object. So objects, rather than just taking one value, can potentially hold multiple values in them. In this case, a glabel is going to have hello world as some text that's going to display in some location that's 100,75. So we say, hey, glabel, you're the class. I don't have an object of you yet. You're the class. When I say, give me a new glabel, it's sort of like going to the factory. You sort of show up at the glabel factory and you say, yo, glabel factory, give me a new object. And glabel factory sort of sitting up there and says, well, what kind of new object do you want? Yeah, I can give you a glabel, but how's that initial glabel going to look? And you're providing these parameters that sort of specify what the initial glabel looks like. So this line has now created a glabel, okay? And it has some initial, so when we execute that line, it has some initial text that it's going to display, and somewhere it's also storing the values 175 because it knows where that's going to be on the screen. Now what we're going to do is we're going to tell that object to do some additional stuff. The way we tell an object to do something is we specify the name of the variable for the object. Okay, so the object name is label. That's the name of the variable. And so that's what we say here. We don't say glabel. We say the name of the variable, label. Then we have a dot. Then we have the name of the method that we're going to call for that particular object. So that's a little bit different than Carol's world, right? In Carol's world, every time you called a method, Carol was the one executing that particular method. Here, when you have multiple objects, you need to specify which object you want to execute this method. So you say, hey, label, yeah, I'm referring to you, buddy. Set your font to be this particular font, sans serif, which you saw last time. Just makes it big. It makes a 36-point font. And then you say, hey, label, yeah, you, same guy, or gal, or it, as whatever it may be. Set your color to be red. And it says, OK, I'll set my color to be red. And then finally, if I want to take this label and stick it up onto my graphics canvas, which is actually the program I'm looking at, right? I've done all this stuff. My program's still bringing up a blank screen. It's like, here you go, nothing going on here. I say add and the name of the object that I want to add, right? Because now I'm holding this little object called label. This is my little felt hello world. And I want to say, hey, take the felt hello world that's so cute and just stick it in the world. So we add it to the graphics program, basically. And it shows up in the screen where it knows it's supposed to show up, at 100,75. Okay? So the general form for this that people refer to when you see something like this, you have name of the variable and the method name. And the Java-esque names that we give to these things, just so when you hear other programmers refer to them, you know what they're talking about, is they say the object is the receiver. So the object here is the one who's receiving or being told to do something. Okay? So the name of the variable is the receiver, and the method that's being called is called the message. So there's this whole notion of sending messages. Kind of like you can think of programming as IM. Right? And in your little IM, you have like your friend Bob and your friend Sally and your friend Dave and your friend Label. Right? And Label's just sitting there in IM. And Label is not very talkative, but every once in a while you can send a message to IM, which is a form of message that Label understands, and then Label will do something. So this is called the message that we send to the receiver, is kind of the nomenclature. But a lot of times you'll just hear people say, I made a method call on the object, and it means exactly the same thing. Again, we like to give funky names to simple concepts. Okay? So any questions about that?
If you add the label first, then can you set the file to change the color?
Yeah, you can still, after you sort of put the little object up there, it says, oh, the object's in the world. Then you can say, hey, object, change your color to red. And that's where it's a lot cooler than the felt animals you had when you were a kid, because it'll just change to red right there on the screen. Because once it's been added, it's up on your canvas. And now any messages that you send to it will actually change its appearance on the canvas. Okay? So with that said, let's kind of go through and understand a little bit more about what are some of these methods or messages that we can send to particular kinds of objects. Okay? So to do that, first let's talk about the graphics world that we live in. There's a couple things you want to think about the graphics world. How do we specify all these things like locations and how is it laid out? Well, the origin's the upper left. So the upper left corner of your graphics window is location 0, 0. Everything in your graphics window is measured in pixels. Pixels are the little dots on your screen. So if you get out a magnifying glass and you go up to your monitor and you look real close and you get like eye strain and then you want to sue, don't worry. It's just fine. At least you saw a pixel and it brought you a little closer to nirvana. Okay? So a pixel are just the little squares essentially on your screen that could actually get displayed. And all the numbers that we refer to are in terms of pixels. So when we think about x and y coordinates, x is how far you go across, sort of across the screen, and y is how far you go down. The x coordinates just increase to the right from 0, 0, and the y coordinates, different than what you're used to in mathematics, y coordinates go down. So normally we think of this as the negative y direction, not so in Java's world. This is the positive y direction going down. Okay, that's just the way life is. It's been there, been like that since I was a wee tyke, or actually since Java came around. Okay? And so you might wonder, hey, so if I have some label like hello world and I specify some location, where is that really on this hello world thing? And so the glabel coordinates, the coordinates, that 100,75 that we gave it, were the x and y location of the baseline of the first character. So they're that first pixel right there on the lower left-hand corner of the H. Okay? And so that's 175. That's how things are laid out. Uh-huh.
Is it possible to specify location using radios?
Well, everything's in terms of pixels. There's some stuff you'll see later on in the class where we actually specify some things like in polar coordinates. If you're familiar with polar coordinates, you'll get to that later on. But you want to think of these numbers as just being absolute pixels. And you can do some math to figure out where those pixels should actually be, but they're still just pixels. Just way off. All right. So remember, all of these classes are organized in some hierarchy. And everything that we talked about, right, glabel, grect, goval, and gline are all G-objects, which means any behavior that a G-object has, all of these puppies have. So let's start off by thinking about what are the behaviors or methods that are available on G-objects. So one is set color. You just saw an example of that, right? You specify the object, you say set color, and you give it some color. I'll show you where the colors come from. And it sets the color of the specified object to the color you just specified as this thing called a parameter. So the thing that's inside the braces, or not the braces, the parentheses, in our formal speak we refer to as parameters. So methods have parameters. They're the values that you provide inside the parentheses when you invoke a particular method. Okay? So there's a single parameter there, color. There's also something called set location, which takes an x and y coordinates. Again, x and y are in pixels, and it sets the location of that object to that x, y. So this method has two parameters, x and y. And you might say, but Maron, when I created the glabel before, didn't I specify the x and y location when I kind of told the factory to give me one of these glabel objects? Yeah, you did, but you didn't have to. And it turns out there's times you don't want to. You want to just say, hey, give me a label that's got the words hello world in it, and later on I'll figure out where it's actually going to go on the screen, so I'll specify what the x and y are. But until you specify that x and y, it doesn't know. But you can specify it after you've actually created the object is the important thing. And move, and here's a funky thing. You can actually tell an object, like you have your little, hello world somewhere on the screen. It's kind of like the furniture idea of objects. You're like, yeah, I don't like how it looks there. Move it a little to the right. And so there's a move method, and its coordinates, if you're sort of a calculus person, are dx and dy. And if you're not a calculus person, don't worry. You don't need to be a calculus. This is the closest we get to calculus in this class. You're like, oh, rock on. Dx and dy just means how many pixels in the x direction and the y direction should you move this object from its previous location. And these can be positive or negative, because you can actually have something be negative, say, in the y direction, it'll move it up on the screen. So it's just the offset, or how much you want to, so think of it as the difference in x and the difference in y. How much do you want to change where it moves? Question?
Can you do set location x, y, and then define x and y?
Can you do set location x? So you,
Type in object.set location and put in x and y, and then later define x and y.
no, if you want to say set location x, y, you're referring to two variables x and y. So those variables x and y need to have already been declared and have values. Yeah, so anything that's a parameter here, you can actually use a variable rather than an actual value, like an actual number. And we'll see some examples of that as we go along. Clipped once again. So where do all these colors come from? It turns out the colors come from a standard library that someone in the Java world wrote that's called the Java AWT package. So if you want to use these colors at the top of your program, and I'll show you an example of this, you'd say import java.awt.star. And these are all the colors. So they're all the name, color, dot, and then what the color actually is. So you just saw an example where we used color.red to make hello world red. But there's all these different colors. And they're all in your book, so you don't need to scribble them down hurriedly. But, different shades of black or gray or white and, magenta and cyan if you're sort of a color photography sort of person. But there's a whole set of colors, and you can just go to town on them. Okay? So all GObject, all of these things respond to these methods because these guys are all objects. So any of those three methods will work on any of these objects of any of these types. But there are some additional behaviors or some additional methods that some of the specialized classes, the subclasses, actually implement. So glabel has some additional things that it does beyond just what a GObject in general would do. And the big one, well, first of all, it's got what we refer to as the constructor. You can think of the constructor, and I'm going to do a little violence to the term, but you can think of the constructor as a factory. Okay? What the constructor says is, hey, I want a new one of these guys. So I use the word new, and then I specify the constructor. Okay? The constructor is the name of the class of which you're going to get a new object, and then some initial parameters. So the initial parameters for a glabel, for example, could be what you just saw, the text that you want to display and its initial x and y coordinate. Okay? There are some other ones. For example, you can change the fonts, right? It makes sense for a label. Like, it doesn't make sense for a square or rectangle to say, hey, square, your font's going to be Helvetica. And the square's like, I'm 4 lines, man. I don't have a font. What are you talking about? Right? That's why the notion of setting a font isn't something that all GObjects have. It's only something that glabels have, which means grect and goval and gline don't have a set font. This is just something that you can do with a glabel. And what it does, it says specify the font that you want that label to show up in on the screen. And the general form for specifying fonts, this is all in your book, and it shows you an example of fonts, but the general form is inside double quotes, because you're going to give it as a piece of text, you specify the family of the font. That would be something like Times or Helvetica. The style of the font, which is it plain or bold or italic or bold italic. So yeah, now in fact you can do like all those funky things your word processor does. And then the size of your font, how big or small you actually want it to be. And you specify that as some text, and that would be what you send over to this set font method to set the text. Okay, so any questions about that? No, you get them all through graphics program. Rock on. All right. So how do we draw some geometrical objects? Oh, another question?
Yeah. So you said we should import Java AWT if we want colors, but do we also get that just importing the graphics program?
If you're doing a graphics program without any colors, you don't need java.awt. Yeah, in addition to graphics program. And I'll give you an example of that in just a second, so I'll actually show you a program that has it. So drawing geometrical objects. It turns out some of these other guys have funky things that you can do specifically with them. So first of all, there's the constructors, the factories from which you can build new things. So how do I make a new rectangle? I say, hey, I want a new G-rect. I specify the x and y location that's the upper left-hand corner of that rectangle, and then I specify the width and height of that rectangle in pixels. Okay? So that's the basic idea, is upper left-hand corner, and then x, y, and then, sorry, height or width and height of the rectangle. Similarly for oval, ovals are kind of funky because you look at this and you're like, hey, I have an x and y and a width and a height. I didn't like width and height like ovals. I thought an oval was defined by like two foci, right? And that whole thing, like when you have a string, you ever do that? You stick the two like nails in a board and you put the string around it and you draw. Anyone? There's like two people. Yeah, sorry. Do it. Go get a piece of wood, stick two nails in it, put some string around it, get a pencil on one side, you can draw ovals. And you can draw like one, and if you're like 6 years old, you'll draw like 1,000. And if you're, 18, you draw one, you're like, yeah, that was just stupid. But the basic idea behind an oval is the reason why we specify it this way is you specify sort of an imaginary rectangle for the oval, and the oval shows up as an oval that just happens to touch the sides of the rectangle, which is how we sort of specify how wide and broad it is. So think imaginary rectangle, and sort of the four ends of the oval would actually be touching it, and I'll show you that momentarily. G-line is very straightforward. G-line, the way we specify a line, just like in the days of yore with Euclid, line is defined by 2 points. Right? That's an infinite line, but we can think of where it ends at the 2 points. So we specify an initial xy location and an ending xy location, and it will just draw a line between those 2 points. Pretty straightforward.
For set location, it's defined as the lower left corner of your object, and the G-rectangle, your coordinates are the upper left corner?
Well, for set location, it's the lower left corner for textual objects. And then it becomes different for rectangles and ovals and stuff like that. Yeah. So it's a slight variation, but that's just because we're trying to deal with text and rectangles symmetrically, and it's tough to do. Okay. There's also some additional methods that are just shared by G-rect and G-oval. They don't actually apply to lines or to labels for that sense. Rectangles and ovals can be filled, so they can either be an outline. You can either have a rectangle that looks just like this, which is an outline, or it can be filled in, which means it just is a big solid chunk of stuff. So you said if it's filled, you say this is either true or false with the actual word true or false. So if you set it to true, then when you draw it on there, you say, hey, put this thing up on my canvas. By adding it to the canvas, it will show up filled in. It will show up solid. And if this is set to false, it just shows up as the outline of the object, whether or not that's an oval or a rectangle. And almost done here, there's also a notion of a set fill color. And you might be wondering, you're like, but Meron, you told me that set color, here's where things get a little funky. You told me that set color was something that was defined for a G object. So if set color is defined over here, doesn't that mean that a G-rect and a G-oval already can set their color? Yes, that's true. So what's the set fill color all about? And this is a slight variation. When you set color for something, you set the color for the whole thing. If that's solid or if it's an outline, you're setting the color for the whole thing. When you set fill color, you are just setting the color for this internal portion. So imagine like this was your rectangle. What color you use to fill it in can actually be different than what color the line is. So if you want the line, say, to be black and you want the fill to be red, you can actually do that by setting the fill color to be red, and then the outline is still whatever the color of the actual object was, if you want to do that. Okay, so it's if the interior is filled, so set fill has to be true, then you can set the fill color to be different. That's a minor thing, but it's kind of fun if you're drawing stuff. Okay, so any questions about that? Wait, we want a question over there?
Yeah, I was wondering, what would you put in the fill for set fill? What is that?
In the place of this word fill?
Yeah.
It's either the word true or the word false. So if you say true, set filled is true, which means it will be a solid thing. It will be filled in.
If when you're using the constructor, you specify a width and height, like initially, then why would you use set location later if it's already set?
Maybe you want to do some animation. So you have like your bunny in the world, and he's going to like move along.
Does that move or no?
Well, it starts somewhere to begin with, and later on, guess what? You're actually going to be doing a program that involves animation. Rock on. And you will move things around. So that's where it comes from. Alrighty. So One last thing that might be useful to you. Sometimes you want to say center something in the graphics window or draw something in the bottom. How do you know how big the graphics window actually is? There's two methods from the graphics program class. So these methods, you might notice they don't have any object that is their receiver. And the reason for that is that both of these methods, their receiver is the graphics program. So if you don't specify the receiver for a method, the thing that is actually receiving the method is the encapsulating class. Okay? Just like in Carol, when you had Carol and you said move, and you didn't specify an object for the move was going to Carol. So get width and get height will return to the width and the height of the graphics window in pixels. So these actually give you back a numeric value that you can, for example, assign to a variable and then do manipulations on it.
If you don't fill in the receiver and you just do something like set color, you change the entire background of the graphics window?
Well, you can make a huge rectangle that's the size of the graphics window and fill it, set it to be filled and set it to be a color, and then you can change the whole background that way.
Can you then change the size of the graphics window?
There is some stuff later on, but for right now, just think of a fixed size graphics window. Yeah. So let me push on just a little bit if we can. Because what I want to actually show you now is a graphics window that makes, or a graphics program that makes use of a bunch of this stuff. So over here, here's a little program called Fun Graphics. Okay? And so we have a comment up at the top, and here are all the imports you need. Notice I commented these for you. We need acm.graphics* because we're going to write a graphics program. We need acm.program.* because all programs that you write in this class are going to need that. And because we're going to use colors, we additionally need java.awt.*. If we weren't going to use colors, we wouldn't need that, but it's needed for the colors.
The program we did on Monday didn't have Java 8, but we changed the source font.
It did. It might have just been hidden. Because sometimes it just appears hidden until you expand it out, but it actually had it in there. So here's what we're going to do. Let me just run this program, show you what it displays on the screen, and then show you how we actually get that display. So it's just like, hey, Maron, you're just drawing garbage on my screen. No, there really is a method to this madness. Not really. There are multiple methods to this madness. I know. Sometimes computer scientists should not make that was actually not a canned joke. That just came to me. How horrible is that? So here's what's going on. We drew a bunch of stuff on that screen. How did it get there? Well, hey, hello world. We probably knew how that got there. This should all be familiar to you now. We got a new G label. We had some variable called label that we assigned it in. We set its font. We set its color to red. Because we set its color to red, that's why we need java.awt, because we're using colors. We set its color to red, and we said, hey, I got hello world. Throw it up on the screen. So we add label. You give it the name of the variable, and whoosh, there it appears. Over here, we say, hey, grect. I want a new rectangle that's upper left-hand coordinate is 10, 10, and its size is going to be 50, 50, which means it is a square. It's not filled in, and I haven't specified its color, right? So if you don't say set fill, it's automatically not filled in. If you don't specify the color, it's automatically black. And then I add it, and then you get that little box all the way up in the upper left-hand corner. Then I say, hey, you know what? I want some other grect that's cooler because it's going to have colors and it's going to be bigger and badder and it's going to be nationwide. And so what it's going to do is I'm going to have rect2, which is another variable of type grect. It's perfectly fine for me to have multiple objects of the same type, which is a new grect that's upper left-hand coordinates is 300, 75, and whose size is honkin'. It's 200 by 100. So it's this big, long thing. And it's going to be filled in, and I'm going to set its fill color to be red. So the whole thing is red. Throw it up there. And so what I get is that big rectangle. Just ignore the big green oval in front of it for right now. I get this big red rectangle up there. And I say, well, that's kind of cool, but I want to see what this oval thing is all about. So, hey, Maron, make me an oval. And I'm like, all right, well, goval will make you an oval. And the dimensions of the oval, its upper left-hand coordinate and its size, are exactly the same as the rectangle. And the reason for doing that is so to show you the oval in relation to the rectangle that you specified. Its set filled is true, and its set fill color, not its set color, but its set fill color is set to be green, which means the internals of it will be green. The outline of the oval will still be black because we did not set its color, and then we add it. And there you get that green oval, and you can notice its four ends touch the same four ends as this rectangle. And if you look real closely, there's actually a green line that demarcates the oval, and then the middle fill is actually green. It might be a little hard to see, but that's the case. Then we also have a line, so I will just call this my funky line. And my funky line is a line that starts at 100, 150, and extends to the location 2, 200, 175. And there's my funky line. Yeah, it's a funky line, all right? And then I add another thing, and you're like, dude, where's my line? And so dude, where's my line is a line that should cut across the entire graphics window, because it starts at 0, 0. Well, not the entire graphics window. Starts at 0, 0 in the upper left corner and goes to 100, 100. And this is a common error, which is why I show it to you. And you look up there and you're like, but Maron, there's only one line, and that's your funky line. Or my funky line, as the case may be. Dude, where's my line? And it's not up there. Why is it not up there? Yeah, you did not add it to the graphics content, okay? Common error. People will go ahead and create something, and they'll add all the colors, and they'll set all the sizes, and they'll be like, oh, I'm rocking, and then they run their program, and nothing shows up, and they start tearing their hair out and beating their section leader, and it's a bad time, and they're sitting there contemplating life in jail, and then they realize, I just should have added it to the canvas, right? But you can't give that as an excuse to the judge, all right? So any questions about that? All right, let me very quickly, I need to push on real quickly. So I want to tell you a little bit about expressions before we finish up. And we'll do more expressions, but you need to know some basic stuff on expressions. All right, so all an expression is you already saw one. An expression is something like int total equals n1 plus n2. This is an expression. It's just some mathematical expression that tells us how things kind of relate to each other. And basically, all an expression is, it's a bunch of terms, and these terms can either be individual variables, or they can be constant values, like they can be like the number 2 or 3, or they could be some method call like readInt that actually gets a value from the user, for example. And there's some operators between them, like the addition operator. And so when you take some terms and you put operators between them to combine the terms, that's called an expression, right? Fairly straightforward stuff. You've probably seen these. There's a bunch of operators you should know about. The operators are things like plus, minus, times, which is actually a star or an asterisk, is how we refer to times. It's not an X. Division, and then strangely enough, this thing that looks like percent. And it's not the percentage operator, although you might think that. This is what's known as the remainder operator. Okay? So these puppies all generally work like you would think. Add 2 numbers, subtract 2 numbers. There's also a unary minus. A unary minus is the funky mathematical way of saying negative sign. So you could actually say like equals negative n1 plus n2. That's a unary minus. That's perfectly fine. Okay? Or you can use that same thing, as subtraction if it's between 2 terms. Multiplication, division. The thing about division that is funky is it depends how division is used. Okay? I'll tell you a little bit more about that next time, but I want to talk about remainder right now. And remember back in 2nd grade when you did like short division and you said, oh, I had 5 and 2. How many times does 2 go into 5? 2. And then you were like, remainder 1. Anyone remember that? Wasn't that such good times? Like that warm. Like I loved remainder. Like that's the only like math. I was like, oh, there. And when the remainder was 0, I got pissed. But that's what remainder was all about. Was just what's left after you do the division. So that's the way you should think about percentage. It's the remainder operator, and you're like, so how does that work? So what that means is if I say 7 remainder 2, the value of this is 1, because it's after I divide 7 by 2, and I see how many whole times 2 goes into 7, what's the remainder? It's 1. Okay? You could say something funky like, hey, what's 7 remainder 20? And you're like, well, 20 doesn't go into 7, Maron, so that would be 0 remainder. Rock on. So that's the way it works. It's not the modulus operator. If you're a mathematician or you've worked with other languages and you've seen plus, and you're like, oh, that's the modulo operator. It's not in Java. It's remainder. And if you try to apply it to negative numbers, unexpected things, well, it's not unexpected. It's just not what you would have expected in a mathematical sense. So as far as you'll see it in the book and everything we do in this class, just apply it to positive integers. And you can only apply it to integers because there is no remainder with real valued values. With doubles, there's no remainder. And so when we come back next time, we'll talk a little bit more about some of these expressions. Any questions before we break? All right, and I'll see you. Oh, there's a question? Why don't you just come up and ask it? Thank you.